participants to keep the cameras off
Um,
just to save some bandwidth?
yeah,
Or
it's that's perfectly fine. Yeah, and whoever's presenting, they can obviously put their camera on, and in the meantime, when they're watching the pictures, they can turn it off. So obviously, save the bandwidth.
yeah, I think it's better for some persons. Yeah.
Yeah, so that's absolutely fine. And that's no, you can keep your cameras off if you need to.
Hi, all. Are we waiting for the jury? June?
Hi, Julia.
Hi.
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 We're waiting for the jury, so I'm just waiting for them to come in. So give them a good few minutes before we start.
Perfect. Thank you.
Okay.
I'll check the sustainability panel and be back.
Awesome.
Bye-bye.
Okay, I'll see you in a bit. Bye.
Hello, everyone.
Hi, everyone. We're just going to give it a few minutes to wait for a few more judges and a few more team members to come along, and then we'll start the session.
Good morning, everyone. Good morning, Cesar. I recognise you as a familiar face. How are you today?
Good morning, Edward.
Nice to see you again.
Nice to see you too. Hi, Flora.
Sorry, I was on mute. Good morning, everybody, or good afternoon, wherever you are.
Indeed.
Good morning, good afternoon. Okay, so I think we're ready to start. I think we're still waiting on Johanna Dunlop to come along, so we'll just give it a couple of more minutes and then we can start the session. Hi, Cesar, how are you?
Fine. How are you? Great to see you. Ready for
Yeah.
another Petroball?
Oh gosh, yeah. Another year of Petrobol soon. It's good to see you here.
Thank you. I have been the mentor of the Team H.
Oh yes, I know you're the mentor. I can see you. Your team have been working really hard.
Yes.
Good. So we have Flora here, we have and we have Edward, and we're still waiting for William and Johanna. So we just give minutes. Or William's just coming in now.
How's it going, Joanne? Everything fine?
Yes, very busy, but surviving. So yeah, so far
Cool.
okay. Well, hopefully winding down for Christmas. So we hope to have a nice little break.
Excellent.
Hello, William.
Hello. Sorry,
How
I
are
was late, but I had some trouble with the connection.
That's
Now
okay.
everything's okay. Okay now.
That's fine. That's absolutely fine. We're just waiting for Johanna, who's the fourth member of our panel, of our jury panel. So we'll just give it a couple more minutes.
Okay.
Okay, we'll start right now. So hello and welcome to today's session. Thank you for joining us for the Ideathon Pitch meeting. So today we will be hearing from the teams who have come together and spent a week to come up with ideas to tackle sustainability issues and develop sustainability solutions for the industry. So the teams will be showcasing their solutions to a panel of sustainability experts, which we will refer to as a jury. So let's welcome the jury. So we have Flora Moon. Flora Moon is the Sustainability Director for Expressworks, a change management consultancy that helps clients navigate systemic change. For SBE, she serves on the Gaia Steering Committee and has authored several papers on sustainability and strategy. She has worked with petrochemical clients, for over 15 years. And in 2020, she received the Sustainability and Stewardship Award from the Gulf Coast region. Flora is engaged in creating capability and capacity in local, national, and international organizations, and is the co-designer of the Sustainability Investment Strategy for Merrill Lynch Bank of America. Flora was an award-winning documentary filmmaker. We would like to welcome William Palozzo. William is the Chief Production and Technology Officer at DG Impianti Industriali SPA. He is an active member of SPE and is the Director of HSE and Sustainability for the Italian section. He has a degree in petroleum engineering from the University of Bologna and a master's degree in environmental site remediation. Next on our jury panel is Edward White. Edward White is a communications manager from IPCA, a communications specialist with over 10 years experience in the public and private sector. Edward has held managerial positions in a national oil company, an engineering trade association, and international climate change think tank. Edward works with IPCA's communications team to maximize the impact of its climate, environmental, social, and sustainability good practice guidance across the global oil and gas industry. And last but not least, we have Joanna Dunlop. Joanna has worked in the oil and gas industry for nearly 30 years, 27 of those years with Schlumberger, where she was a risk manager for the first 5 years and subsequently devoted her career to topics at interface of the companies and society, serving as internal thought leader. She is now a membership engagement manager for the International Association of Oil and Gas Producers. She is an active member of SPE, notably as the founding chair of the SPE Sustainable Development Technical Section, board member and technical director for HSE Sustainability, and the founder and chair of the Gaia program. So thank you very much to jury for your contribution to this event. So let's start with how today's session will work. All teams have 5 minutes to pitch, 3 minutes for Q&A, and 2 minutes for the jury to vote and submit their scores. Once the teams have pitched their solutions, the jury their scores. Jury, you should have been sent a form, a judging form to submit your scores. So if you don't have this, just please let me know and I can send you the form via direct message. The award session will be taking place in a different Zoom meeting. So after this has concluded, the award session will start at 10:30 CDT. So it's the same exact Zoom link, which the sustainability panel is taking place right now. I can send you the link in the chat, and so if you don't have that link, I can send that to you. So just some background about the Congress. This is a collaboration between BMLC, WIMEC, and also the SPE Beyond the Borders. And we're also supported by the Gaia Sustainability Programme and the DNI initiatives. The YP Congress is supported by Shell, so I would like to take a moment to thank Shell for their contribution. They are very supportive of student and YP activities, and they have really helped support in the participation as well as financially supporting the event. So a big thank you to Shell. So let's start. So today we will be presented with the pictures from groups H to M. So without further ado, let's welcome the first team, Team H. We have Team H's mentor, Cesar Patino, and our participants in Team H are Nikhil Kulkarni, Jamila Rahman, Abdul Hamid, Ranel Ghalib, Obianuju Isicheli, Islam Ez Kamil Mohammed, and Hilary Obugayahi. So Nikhil will be pitching for the first. Nikhil will be pitching for the first team, for the team. So please go ahead and share your screen and start. You have 5 minutes to pitch. I'm just going to make you co-host, so you have the function to do that, Nikhil.
Okay. The time will start once you make me a co-host, right?
Yeah, I'll let you know when to start. I'm just sharing my screen.
Okay.
Okay, Nikhil, are you check that you can share your screen?
Just a second. Something changed with Zoom.
Yeah, it does. No problem.
Yeah, just give me a second. I guess so. Please let me know once you're able to see my screen. I'll turn off my camera, or let it be. I think that should be okay. Is it visible?
Yes, we can see your screen, Nikhil.
I see Johanna is in waiting room. I see that.
Perfect. Thank you. I'll just let her in.
So, yeah. Okay. All right. Should we wait till she joins? Or?
Yeah, we can wait. We wait till she joins.
Yeah.
I think Joanna say is on. Joanna is here.
Yes, she's in now. Yeah, she's
Okay. So should we
trying
start?
to connect.
I apologize.
Hi, Johanna. Thank you for joining us. No problem at all. Thank you so much.
Thank you.
Okay,
All
Nikhil,
right.
so you can start your presentation. So you have 5 minutes.
Awesome. Thank you very much for having us here. Thank you, SPE YMIC and the juries for your time. Just give me a second. Yeah. So this is Team H, and our product is SEES, Sustainable Ecosystem and Energy Solutions. I am Nikhil Kulkarni. I would be presenting on behalf of our team. The team was introduced earlier. Why is it not going ahead? Okay, sorry. So I'll directly jump into the product. So our product is, so we are addressing one problem. The problem is of poor supply chain for waste management and energy distribution. Our solution offers AI-powered app catering to supply chain of waste management and energy distribution issues. This is specifically a very crucial issue and definitely a need of the hour. Because in most of the places in the world, e-waste and waste management is a challenge. When we speak of sustainability, I would like to share, share that sustainability means different for a company, for a country, and for every country in the world. Sustainability means something different. And same would be true for everybody on the panel as well. So if you want to address everybody and anybody, maybe that might not be possible. However, there is one definite problem that exists for everybody, and that is around waste management. Can you see this? Do you know what is this? This is a glucometer. So anybody having sugar problems would be using this. And if you see this, if it would have been a real life picture in person, then it would have been better. But it contains radioactive material. So this is the need of the hour. Waste management is extremely crucial. For that, we are building our app. Our app would address supply chain management of waste, focusing on recycling with primary categories of domestic waste, industrial waste, automobile waste, plastic waste, and of course, e-waste. Our second phase would be we'll be collecting data, and we'll be using the consumer data to analyze energy distribution and subsequently deploying wireless cables. However, for the presentation, for the pitch, we are only considering phase 1. There is a plan which I'll briefly share for phase 2 as well. So this is our SWOT. We have first mover advantage, simple to create app, modular to move with multiple businesses. It's authentic data generated. The product developed can be replicated with energy distribution systems and can be B2C, B2B, B2G, different places. The biggest threat that I would like to share is changing government policies and getting the delivery personnel, because at the end of the day, you are dealing with waste. That might not be true for everybody and anybody around. The biggest weaknesses is driving behavioral change of users and customers, and it's a completely unstructured market. However, these are opportunities as well. So this is briefly SWOT. We are addressing multiple goals. Sorry, I missed on sharing this one. So this is our primary goal that we are addressing: industry, innovation, and infrastructure. However, we are also touch basing others. So these are the goals which will be directly addressed and goals tangibly addressed. So life below water and life on land. That's also getting affected a lot due to waste. Briefly touch basing our business model. So we are primarily targeting India to begin with and slowly replicate it globally. I know in India for sure there is definite need for this. There is no parallel competitor for this one. So, you get tremendous e-waste generated. We are second populous country in the world. So a tremendous amount of waste generated, e-waste generated every day. Informal sector, it's a tragedy, but informal sector is collecting more than 10,000 tons of reusable waste every day. And, sadly, that too without PP. So implementing this will definitely address a very different issue, a very different area, even helping the workers who are in that sector. This is the supply chain. So waste generation happens, waste is processed, waste is consumed by consumers, and then the process waste is deployed to end user, and all can be addressed by the app. So the waste at the origin is collected by an agent like your Amazon agent, and then waste is processed and then shared with the world. So this is briefly costing. We are well below 3.72 million. Other initial expenses, so our mandatory expenses is 220,000. Other initial expenses are in the range of 3.5 million. But if we can have a good strategic partner, we will be able to easily do that. These are the different subscription plans we plan to offer to different users. And we have defined the life cycle as well. So this is the app life cycle. We intend to attain 100,000 downloads by 188 day, and by a year we want to have 1 million, and that's pretty much possible by in a country like India. So again, different phase of life cycle. So again, touch basing the phase 2 when we start, and how do we take it up, and of course business. So when we take up, when the beta integration happens, those things. So this is our team. We had 100% virtual and never met before, and had a great team. Thank you, Caesar, for all the mentoring and help that you had. So this is briefly our idea, and with that, I would conclude my 5 minutes.
Thank you for your pitch, Nikhil and team. We would now like to invite the jury to ask any questions. Jury has 2 minutes for any questions.
I guess we've all been polite. Thanks very much for that excellent presentation. I had a good look through the slides as well, and I think you've identified a problem really well. The key stakeholders, I like the barrier that you've sort of identified a key barrier and perhaps ways of overcoming that with I think the bonus for the initial free use and bonus for the client, the general people. So really well thought out presentation. I guess just be interested in, if we take one of the stakeholders, say the everyday user, how would they use the app? Just a bit more information. So your sort of general public, they've got this app. What would they do with this?
So like any other app, like AWS, or I'm sorry, not AWS, like Amazon app, there will be different users. So if you go here, yeah, even this slide would be good enough.
Yeah.
So individual users, they would have a different UI where they can log in, and like you order on Amazon, they can book an appointment, or your Uber app, you can book an appointment. So waste buyer, waste processor, and process buyer, they can belong to the same app, or we can have different UIs. I think that's only jargon. We can have things at the backdrop. And associated services, they can also be associated. So we would have 2 or 3 apps which are, and these days, in India, if you go to remotest of the village, you would find people are very well versed with the digital technology. They can use all the apps, like right from Amazon to Uber and everything. So ordering or using this app would not be a challenge. Definite challenge that I shared is making people, I am a lazy person, I don't want to use that. So making sure that they take it, and that's why this incentivization is there. So this intensive is kind of economic incentivization, that green bonus, coupons, or carbon credits, so that they can take the credits and sell out in the market. So this is something that behavior that we'll have to drive. But to begin with, in India, I'm quite sure, convinced that once the app is launched, and if we can have a good partner to take the app to the public, we can make sure that we'll have a very good. So 1 million downloads in a year is I think very conveniently achievable target.
Thank you, Nick. An excellent answer. Yeah, and I really liked how the incentive linked to one of the key barriers, the behavioural change. Thank you.
Thank you. Johanna.
Yeah. Hi, Nikhil. Thank you very much, and well done, team. I wonder if you could tell us a little bit about, how you're going to manage verification and auditing.
Verification of ordering. So mostly, yeah, please go on.
Yeah, no, verification and auditing to or certifying that people are actually doing, or stakeholders are actually doing what they've said they're doing.
Okay, so individual users, maybe that might be an area of challenge, and that will be an area of challenge. However, in India, we have waste segregation, we have color coded, and many people do follow it at large. And if they are getting, this incentivization and categorization of the app, which I showed, I speak very fast and it was only 5 minutes. So this categorization, so different category would have different incentivization at different point in time. So this would help us run a behavioral change in our users, these are individual users. However, for buyers and processors, there is a definite, so Government of India has definite certification system. So that system can be implemented very easily. So I'm not much worried about how we can do that. So verification is pretty easy. We can use AI powered app. There are many APIs that government offers where you can go and verify certification of a company, verify business model, business or existing business case of a company. That can be done very easily. So I'm not much worried. But however, yeah, that's a valid point. I must say. So here I'm not much concerned about these services, but individual users, yes, there we will have to drive a change. But eventually people get adapted to it. This is something that they are also facing. They are also suffering. Government of India recently has, for last few years, Government of India has Swachh Bharat mission, means Clean India movement is happening across the country, and this thing is taken up very seriously. So Government of India is already implementing this, driving this change, and that also helps driving this change. One specific part I would be concerned with is associated services, because that aspect may be, if somebody wants to provide a truck for carrying load from one place to other place, that part of the service may become a bit of tricky. However, having some partners, some third-party vendors who are taking care of it would simplify the business and solve the business. And of course, to add to all this, if we can have a good partner, we have a couple of people on our thoughts. So this expenses they totally go off, and leave 5 million. We can have our app ready at 220,000 US. This number is only to scare everybody. Well, big money spent. No, but this is in rupees and this is in USD. Again, this number is extremely high. In India, I'm mentoring a few startups, and I know, if I give this money, they will come up with a different world altogether. So even if you divide by 10, I can have my first pass app ready pretty soon. So which is in the phase. So first phase, first app I can have very, very soon with really high end and top end people. So this overall addressing these concerns, I think right from folks who verifying the individuals to verifying the buyers and users is very easy. And on top of it, these days everybody has mobile, and mobile is linked to everywhere. So you can actually track a lot of things.
Thank you. Well done.
I think one more, somebody else also had a hand raised. Flora.
No, sorry, it was me, William, but you already replied to the previous answer. It's okay.
Did I answer your question? That's great. Thank you.
Thank you.
Flora. Thank you, William. Flora.
Yeah, so I have a question around how would you identify willing partners? Because what I see is a really great implementation plan based on developing your app and sort of who the app will serve. So how do you expect that you would get this to market through some kind of partnership? Have you given some thought to that?
Sure. So in India, so of course, the best dream case, the dream company to help with this app would be, of course, Amazon. They have a very great presence in India. But apart from Amazon, we have local Amazons as well. So companies who have their own distribution systems, and often these companies are quite proactively connecting with startups and of course large corporations as well. So getting a buyer to help us with this, I think that should not be a problem, because in India, I must say that we have second highest number of startups in the world after the US. So pushing it and getting some existing distribution system would not be difficult. And on top of it, in India, the postal services, so government post offices, they have tremendously strong strong system. So maybe not collection of the waste, that might not happen through them, but we can have collection centers at them, and our local bodies. So we call them municipal corporations in India. So municipal corporations, gram panchayats, and local village bodies, they do have their mechanisms and systems to collect waste. So instead of going, and they also they do segregate their waste. Most of them do. I would not say 100% of them do, but many of them do. So it will be easy to begin with, and once we are able to drive change with some use cases, it will be very easy to replicate. And I'm quite happy to say that the current government is very helpful in that sense. I'm sure that Flipkart and Amazon would be quite interested. I would like to remotely touch base. So I know one big. I would not get into details. I know one definite project where of one oil company who would also be interested in helping this project, because they are proactively working they would be able to make much use of this for collection of waste, and I know that, but I don't know how much should I be sharing, because that's through personal conversations that I have learned. But this is definitely they would also be interested in helping this project if something like this comes up.
Thank you.
Thank you, Flora. Sorry, I'm extremely sorry. I'm having a bit of cold, so my voice also might be a bit of busy. I'm cleaning my own nose in between, so sorry for that. Yuan, I think you're speaking on mute.
Yeah, sorry. Yeah, thank you, Nikhil. We will now move on to for the next pitch. We have Team Aqua. So we have Team Aqua's mentor, which is Amina Dan Madami, and the participants in Team Aqua are Muhammad Usman Ayaz, Ali Akbazam, Solomon Ishave, Destiny Otto, Raji Abdullahi Edakola, Alexandra Bogdanovich, and Roberto Caseta. And I believe Alexandra and Roberto will be presenting, and I have already made you co-hosts. So please be ready and share your screen.
Thank you.
Okay, I'm sharing my screen. I hope you can see it. I put in presentation mode. Do you see it? Please give me feedback.
We see it.
Okay, so Alexandra, if you want, you can start.
Thank you. So, hi everyone, my name is Alexandra, and today I will be presenting for Team I along with my teammate Roberto. The topic that we choose for today is water injection system revamping and optimization in an operated oil and gas field. So as we will start with the need and the setting. So as we are all aware, water is a precious resource and it is needed in pretty much every aspect of our everyday lives. And although our industry is not a significant water consumer when compared to other industries, its demands can have a great impact on water resources and can greatly affect human needs. This is often the case with water injection requirements. There is an increase with demands in energy, there is also an increase in the need for water. And as we all know, water is an irreplaceable resource, so its waste must be minimized at all costs. This is why water management is one of the biggest challenges for our petroleum industry. Leakages in surface facilities pipelines also represent a great problem when it comes to waste of water. And since the losses in the leakages reach a very high percentage. So there is also the problem of damaging the surrounding environment's water quality through spills, leaks, inefficient treatment of wastewater, etc. So here on the slide, you can see two graphs that represent how much water is consumed all over the world in oil and gas extraction. So to achieve the sustainability goals that we aim for, that are clean water and sanitation and industry innovation and infrastructure, we are choosing to revamp the water injection process, which would lead to less water waste and more clean water. So Roberto, please, you can take over.
Thank you, Alexandra. Can everybody hear me? Okay, so we now are talking about how our solution is the best for doing this. Now we are dealing with oil and gas infrastructure surface networks. Okay, there are systems that are done to identify leakages in hydraulic networks for urban smart cities. They are using SCD to do this, but we think that for do that in an oil and gas infrastructure, it wouldn't be enough. Indeed, we don't have so many nodes to perform calculation accurate and to and not too much redundancy in our network. So first of all, we need to install apart pressure and flow meters data, also ultrasonic sensors. Ultrasonic sensors are also used in monitoring on structural health on steel buildings and could be used also in pipes to identify the exact position of the flows of the network. Then the system will be integrated with a machine learning algorithm that could help to perform a predictive maintenance operation. And so it will be necessary also the point 3 to implement some modern automation system to minimize the OPEX of these operations. But now we talk about the strategy, why we want to do this. We want to get in line with stakeholders as much as we can on this topic. Indeed, water management tends to be highly impactful factor, and it will be a great opportunity to get in touch and get more recognition from the communities that are living very close to the fields, because they will have a more easy access to water, since we are trying to waste less water. By 2050, there will be an 80% increase in water demand in cities. So water injection system revamping will contribute to solve this challenge by saving more recoverable water. About the planning results, what we are dealing with is an engineering system. It has to be customized to the surface network that we are dealing with. For example, many factors are influencing the design, like for example, the number of nodes, the length of the network. So we have a design part. Then obviously there is the execution, that is the installation of the sensor, the communication infrastructure, and the automation. And then we have to perform operation as we described. What we want to get is to reduce the losses to minimum feasible, because we know that depending on the status of the network, they could reach easily more than 20%. So we want to reduce it to minimum feasible, that is not less than 5%, but it will be something really, really good. Obtaining target production and pressure maintenance of reservoir would require less water, because now we know that we are injecting a lot more than necessary, because we are wasting a lot of water maybe into the desert. So no one could use it anymore. And so we want to guarantee to local communities easier access to water resource. I think we are finished because you introduced the team. Anyway, we are Osman, Ali, Solomon, Destiny, Abdullahi, Alexandra, and me, Roberto. And now we can pass to the question and answer. If you have any question.
Thank you for your pitch. We would now like to ask the jury for if they have any questions.
If it's possible, I've got one question. It's William.
Thank you, William.
Talking about the oil and gas company, do you think that they need some improvement to develop this kind of project in terms of resources of people involved?
I think yes. I think that is a topic that needs for more attention from our from the sustainability departments of major companies, because we know that the problem of leakages in surface facilities, maybe also we're talking about water, so not properly of pollution, okay, but in terms of waste, it is a big a big topic. It should deserve more attention and, of course, more resources.
Okay, thank you.
Johanna?
Thank you, Johanna.
Sorry, I was on mute. Fascinating. I'm just wondering, what was the most challenging aspect of developing this project for you all?
Maybe if I correctly understand the meaning of your question, SCD systems are existing. We know that there are places where they are development. So maybe it looks like there is not much innovation, but I believe that they are not existing in any surface facilities for field development. So this was the biggest issue. Maybe to have the courage to present something that maybe could not be look as so much innovative, but really deserve some attention. I think this is the answer to your question.
Thank you, Roberto. Thank you. Well done.
You're welcome.
Okay, I think that will be the end for that will conclude our Q&A session. Thank you, Team Aqua. Thank you. So we will now move on to Team J, team name Coatry. Team Coatry's mentor is Riverson Opong, and the participants in Team J are Alina Muratov, Arsenij Fyodorov, Shubham Bhavin Patel, Sarah Abdullah Ali Begum, Brian Reinhard, and Okinheng Omulawabi. If you can confirm who will be presenting or pitching, and I can make you co-host so you can share your screen.
Okay, so from Team J, I will be presenting the slides, and the three of my friends will be delivering the presentation.
Okay, Brian, I have made you co-host, so you should be able to share your screen.
Okay, let me have a moment.
No problem.
Have you seen my screen?
Yes, we can see your screen.
Okay, thank you.
Okay, so I will start on behalf of. Can I start? Are we ready?
Sure, yeah. Whenever you're ready.
Okay, yes, so dear jury, we're all happy to be here today. We're the team CO3, and the topic of our presentation lies within our name. And our topic is the utilization of CO2 artificial tree for a better future. So before us is a slide that attempts to make a case for carbon capture and extraction methods. The Paris Agreement captured the need to get to net zero carbon emissions by 2030. The energy transition journey is a good cause, but the huge investment that is requires, coupled with slow progress and uneven spread amongst nations, are major challenges which may take it beyond 2050 to achieve all desired results. So apart from the energy sources, there are other significant contributors to CO2 emissions, like agriculture, industrial processes, and others. So even though the energy industry witnesses the energy transition to achieve net zero, coupled with a bid to stem the emissions from other sources, the world needs to clean the atmosphere from carbon dioxide now. And Rio de Janeiro has been selected because it is one of the 4 cities with the highest increase in per capita in CO2 emissions.
Of all the things that have been stated from the previous explanation, our team has been working tirelessly to construct ideas for innovations and also its implementation and impact for the future. We make progress, we create the breakthrough. On these days, throughout the implementation of the conventional carbon capture unit, the facts, we found that it has some deficiencies. Coming to the rescue, which is the most efficient yet least expensive CO2 extraction method, we present to you as an alternative the artificial tree. As you can see, we can cut off the workflow of the conventional carbon capture unit by using the artificial tree. Manufactured by the main technology, the ion exchange resin, using this resin delivers a fast kinetic reaction. It's able to regenerate with a low energy barrier to complete the entire CO2 release capture cycle. It plays the role to boost the CO2 capture release cyclic, which makes artificial tree 3,000 times faster than the real trees. It doesn't require high maintenance, and it only spends 305 kilowatt hour per day. In addition, we could use the solar panel to support the electric consumption. IR a suitable material for artificial tree as a carbon capture unit, which is the most effective, low cost, energy efficient, and driven by the humidity of the surrounding environment. I will be taking on the economic analysis. The graph shows that the different prices of CO2 from these different technologies that are available to us. The graph compares the price for CO2 from these different technologies, and it's important that we examine the economics of these technologies with that of artificial tree. The graph shows that the price of CO2 can be reduced drastically by the use of artificial tree. The comparison between the conventional carbon capture and the artificial tree shows that the price per tons of CO2 produced from artificial tree is way lesser by a 40% of reduction. Therefore, it improves the ability of CO2 for CO2 injection EOR mechanism in the city of Rio de Janeiro. To reach our sustainable goals, we take our first step by installing the artificial tree in sector area with high level of CO2 concentration. Then we can go with the utilization of CO2 extraction in supporting the other UN SDGs. We break down in three main actions. These three main actions are CO2 extraction delivers us to an action where we can increase the recovery of hydrocarbon by using EOR CO2 injection to maximize the recovery rate in metro fields, and also we can support the energy demands. And obviously, our plans include to force down the greenhouse gases emission. Therefore, we can create an action to overcome the climate change. Last but not least, the CO2 extraction also a product. It will become of value for money, which opens a new opportunity to a world of CO2 businesses or market. It's a third, but it can be a valuable thing. Depends on how we deal with it.
Information about members of our team can be seen on this slide. Our team consists of representatives from Ghana, Nigeria, India, Indonesia, Lithuania, and Kazakhstan. Even though we are from different cultures, from different time zones, just in 1 week, we were able to reach an agreement to find solution of the problem related to utilization of CO2 emissions, which is considered to be a common issue in the energy sector. Thank you for the attention. We'll be pleased to give an answer for any questions.
Thank you, Team J, for your pitch. We would now like to invite the jury to ask any questions. Flora, go ahead.
Yeah, I'm wondering if you gave thank you for the excellent ideas. I really like this presentation. Did you actually give some thought to comparisons with current direct air capture, since this seems to be in competition with, or as an alternative to CO2 capture? So instead of EOR, are you looking at the other technologies as well?
Yeah, we have compared to the current capture techniques. Besides, as we already mentioned before, for the artificial tree itself, giving the most optimal carbon capture from the ambient air rather than any other. We give in a conclusion that the artificial tree giving the best result, and also if we relating it to the its economical, yes, it is. It could brings up to until the $30 per ton, and it's very competitive between the other carbon capture techniques.
So the follow-on is the sort of flexibility of the installation. Is that the attractiveness of the artificial tree because of the footprint?
Yeah, for the yes, it's true, because the artificial tree itself has very flexible manufacture design, because if you can see that from the slide, it can be placed in a strategic places, because the main function of this artificial tree actually just get all the CO2 and then they can extract the CO2 just from the ambient air. And if you can see from the real action by the Klaus Lackner, so the creator is Klaus Lackner, and this artificial tree actually placed nearby the road where the main transportation he focused on.
Thank you.
Okay, thank you.
Any further questions from the jury?
Yes, one question from me, William, if it's possible.
Go ahead.
Yes, talking always about the location. So it's better to locate this artificial tree very close to a source of CO2 in terms of performance, or we can put wherever we want, even maybe where there is not so concentration of CO2, to let them work, have a good performance.
Okay, so where we can put them, I believe the efficiency where would be next to the flare. So if it's possible to put the artificial tree next to the flare, then that would be great.
Okay, thank you.
Am I allowed to ask a question?
Yes, go ahead.
Yeah, I just wanted to get a sense of the if you had any time to look at the economics behind this. When direct air capture gets highly criticized on an economic basis. So just wonder, okay, you've got some economic. Can you just speak to that a little bit more, please?
Okay, so if you see the from the graphic itself, the CO2 cost commercial. So right after the all the operational cost and operational cost, and also they've made it to until the cost commercial. So it's ready to be buy. And if you see in the graphic, we divide it into three groups. The first one is unfavorable, and then the second one is less favorable, and the third one is the most favorable. And we try to compare before the artificial tree, the most effective and efficient is come from the conventional carbon capture unit, which take price $47 per ton of CO2. And then we try to add the artificial tree. We wanted to see whether if it can compete with the others. Then we made it, and then we got the price to the lowest price of artificial tree could produce per ton of CO2 could reach $30 based on our references. Throughout that comparison, we take the conclusion that artificial tree is ready to go for the CO2 cost commercial or CO2 market.
Excellent. Thanks very much, Brian.
Okay, thank you for the question.
Okay, and Edward, you can ask your question.
Yes, thanks very much. Excellent presentation, guys. And my question was going to be very similar to William's about location, but yeah, I guess just a quick comment. I think this is a really well thought out commercial proposition. I think quite a timely one as well. As I think you talk about being used in mature fields. So this time when we're talking about no new investment, I think that's a topical area. I guess just from that commercial element, I guess I took away from it your key sort of customer would be to inject into mature fields. Is that correct, or was there any other audience or stakeholders that you had for this as a commercial proposition to sell the CO2?
So I guess I will take this one. So yeah, we're gonna focus on the mature fields. Actually, those fields who focus on miscible gas flooding EUR techniques that can actually utilize this CO2 that can be captured by our artificial trees. So that's going to be the efficient choice for the putting the trees, because the transportation costs are usually high for such kind of CO2 processes. So we believe we're gonna focus on those fields who are actually like utilizing the EOR techniques related to CO2 injection.
Great, and I like that answer. You've thought about the transportation as a cost and element and location. Great, thank you very much.
Okay, so that concludes our Q&A session for team, that was J. So next we will move on to team K. Team K's mentor is Maria Julia De Dono, and the participants in the team J are Max Walter, Patrick Izanaki, Daima Yashipalish, Shailen Dressing, Mehdi Mezadi, Harsh Qatari, Abbas Abdulatif, and Ikpabi Prince Bernard. I believe Max and Patrick will be presenting, so I'm just going to make a co-host.
Yeah, this is true. Thank you.
Thank you, Max.
Let me see. Can you see the presentation?
Yes, we can see a presentation.
Oh, wait, I think I still have turned off my camera. Wait. So I think now it should work, yeah?
Yeah.
Okay.
And your presentation.
Great. So, all right. Patrick, can you also maybe say something so that we know that your mic is working?
Hello.
Okay, great. Okay, so let me start. Welcome, everybody. Have you ever heard about renewable gasoline? For this, we will now present you our Blue Water project. With this project, we want to focus on the UN sustainability goals, climate action, and life below water. To improve biofuel production, our idea is to use decommissioned offshore platforms to create an algae farm around it. The huge potential of these algae results as they have the highest biomass production per area and only need CO2 and sunlight to grow. Also, they exist in a huge variety so that different types of algae can be selected for different conditions. The current challenges with the algae farms are still that they require high costs, which make them non-competitive to other biomass production methods. These costs especially result from the high prices for the required technology and for harvesting the algae, as well as the high costs for building the algae farm. Therefore, we want to cut costs of major components to make the usage of algae as a green energy source more commercial. In the next decades, more and more platforms have to be decommissioned, and instead of just removing the structures, we want to give them a new purpose. In our Blue Water projects, the platforms will be used as a central hub to build an offshore algae farm around it. To increase, with this, we can use the structures to connect our nets with it. Also, we can use the platforms as treatment facilities or for maintenance. To increase the benefits even further, we also want to inject CO2 into these algae fields to increase the growth rate and reduce the environmental impact. By this, we will also reduce overall CO2 emissions and CO2 emissions of the operating company and avoid related costs. And for this project, Norway and Equinor are predestined as they combine huge offshore engineering and fish farming knowledge, and both are at the forefront of innovative energy ideas. And together with these companies, as well as some companies who already have expertise in algae production, we can bring this project to the field.
Okay. So our Blue Water project is linked to the energy industry. in the sense that algae is a carbon neutral source, right? So it has so many advantages. It's a third generational biofuel. And we already have potential partners like Exxon, BP, refiners, Total Energies who are deep in research of this project. So we have power plants plus algae farm, which will give us a healthier earth. What are we trying to achieve? Energy security. We're also trying to achieve getting climate action, and we're also fighting for energy poverty and food poverty. Okay, so we have potential competitors like offshore wind and solar energy. And we also have electricity produced from algal biogas that can be cost competitive with solar thermal, PV, and biomass generated electricity. We are trying to also help reduce CO2 level in water and air, reducing pH effects. In our path to reality, our Blue Water project utilizing algae satisfies so many United Nations Sustainable Development Goals, but we are particular about climate action, life below water, affordable and clean energy generation, and also industry, innovation, and infrastructure. And at the end of the day, we intend to partner with the right companies, which is in line with Sustainable Development Goal 17. All right. So our economic feasibility is it's crucial to cut the capital cost of several components like pond linings, land lease, recovery, and extraction devices. We have our development steps here: selection of platform for field trial and example, partnership with partnering with University of Stavanger and local fish farms with field, adequate monitoring of growth field, cost-effective harvesting of algae from field, and we will refine this into biofuels and other products by process optimization. We cannot live without saying have huge environmental benefits, which is climate and life below water improvements. And we also have a social benefit of achieving or harvesting clean energy and food for consumption. And at the end of the day, we are going to help mitigate climate action, reduce greenhouse gas. And it's safe to say that our Blue Water project is a good business investment. Our dear jury, you should be convinced that our Blue Water project is good. It's a good investment, since we're also trying to fight for a fossil fuel future. Below is our team members from various parts of the country. We have Mats, we have Yash, we have me, Patrick, we have Prince, and we have our dear Julie. So we have worked tirelessly to research on this project. So we expect your questions and comments. Thank you.
Thank you, Team K, for your pitch. We would now like to invite the jury to ask any questions. Go ahead.
Yes, Edward, I think you're first.
Neck and neck between Joe and I there. Great presentation. I really like this a lot. Just my initial thoughts with anything offshore is the logistics sides of this. So you talked about the driving down costs and the economic feasibility. I guess just a bit of detail on how you'd see that as overcoming these challenges working offshore and North Sea with maybe particularly rough conditions, and how that might affect how you went about things.
Yeah, actually, I think one of the main challenges for building these projects offshore are the construction of a farm or a facility for this, and we want to reduce and avoid these costs by using decommissioned plants that are offshore platforms that are already there, and they, instead of removing them, we want to use them. We want to connect our nets, for example, the nets with these structures to make them to protect them against like getting floated off by storms or something like this. And the surface facility of the platform, we can use like pumps on there and also some other surface facilities that are already there, and want to adjust them like into so that they, for example, the pumps will be used as like a suction pump to collect the algae, and then we want to let it run over filters. And we want to use the already existing infrastructure to avoid costs. And especially like Norway would be like predestined for it, as even many of their platforms are already electrified. So if, of course, we want to maybe combine it with renewables also, like solar or wind on the offshore side. But if this is not possible or like not there, then we can maybe use already the electrification of these platforms to also avoid the further costs.
Thanks, Matt. That is a really great answer. I really like that idea of reusing or repurposing, and explained really well. Thank you.
Yeah, you're welcome. Thanks for the question. I think second was Johanna, I'm not sure.
Yeah, Matt. I'm thinking about impact, and I want both your intended impact and your unintended impact. I wonder if you could elaborate a little more on what this looks like at scale and in terms of impact on emissions. And then secondly, have you given any thought to the unintended impacts, and perhaps speak more to the unintended impacts?
Okay. Like, of course, our idea is now to use this as a green source for biofuels. So to be CO2 neutral with these sources, and also increase, like if it's applied by an energy company, you can increase or improve your overall CO2 emissions if you even like, selectively inject this CO2 into these fields, because these algae basically grow by sunlight and by CO2. So by this, you will burn this CO2 when you use these green fuels, but you capture it again. So it's like more or less net zero. And unintended environmental impacts might be, an uncontrolled algae growth, which we don't want to have, of course. But I think it's also like, it's like, if we do it in the North Sea, first of all, it's like, even though we build big fields and big farms, they will still have like a so small portion in the North Sea itself. It will be on the scale, I don't know, 0.0000 something percent. So even though we have like maybe a higher or unintended high growth rate, we have more than enough time to mitigate this with measures. And also, I think, like, for example, in the North Sea, as the water temperature is a bit cooler, I think it's also easier to control this growth rate.
Excellent answer. Thank you very much, Mats.
You're welcome. And I hope we still have time for William, maybe, for his question.
Yes, please. In reality, I've got two questions. One is considering the economic side. If you consider the fact that you are talking about a platform for decommissioning, so it means that platforms are very close to at the end of life in terms of design and operation. So you have to take care about all the new assessment to give the guarantee that this structure can be on site for another 10 years. So these are costs, so to be taken into consideration into the economics. And the other one is, if you have made an assessment of which is the best location where to put these, let's say, facilities, considering the difference between a climate like North Sea, which is very cold, or Gulf of Mexico. So it depends by the rates of grow of these algae. So we can be the best location of this field to start to grow.
Okay, so like, let me try to answer the first question first. To extend the lifetime of the platforms, I think there are like many platforms that they could be also extended for oil production. It is they are just like decommissioned because it's not economical to produce from these fields anymore. And also as we remove basically a lot of the topside structure, you have like, and you don't have like oil production. So I think even like if something kind of happens, there's not like such an environmental impact. So I think it is possible to extend their lifetime and to get the permission from the government for this, especially as, for example, in Norway, the government actively like supports such projects and new ideas for new energy approaches. And these platforms are also just a suggestion. Of course, we can also like offshore wind farms that are currently constructed can be like used to include these algae farms as well. So I hope this answers your first question. And like coming to the second question, there are like very variety of algae which can be used in different conditions and like have different growth rates in different conditions. So I think you can always like select which type of algae will be optimal for your like water, like salt content and temperature, and also pH in the water. In general, I think that like, you know, in like hotter waters like Gulf of Mexico or even like Mediterranean, the growth rate will be maybe faster. But now in our like Blue Water project, it's like to show that it can be actually done in the field. And for this, I think that Norway and the North Sea will be like a very good possibility, as we said, like, you know, Equinor is like looking for new energy sources and like new ideas, and Norway is actively supporting it. And also, even, I mean, Norway is no member of the European Union, but the European Union is very close. And I read a lot and saw that they also have invest a lot of money in like new biofuel sources, and they want to develop this field. So I'm optimistic that you can even get like more funding from European Union and from Norwegian side. And it's like also to create a role model, basically. If you can see, or if people see it can be done in North Sea, it is economical there, then it can be also done somewhere else.
Okay, thank you.
You're welcome.
Okay, thank you for the jury for your questions. That now concludes our Q&A session for Team K. We now move on to Team L, team name Synergy. Team L's mentor is Pandele Nukile, and the participants in Team L are Lorenzo Monaco, A.M. Rishal Dadin, Ahmed Al-Damiati, Ila Muzan, Yogashri Pradhan, Shirili He, Ayomide, and Adekoya. Can you confirm who it will be pitching for your team, and I will make a co-host? Team L Synergy.
It will be me, Ewan.
Okay, Albert. Thank you.
Thank you.
I'll make a co-host. Bear with me.
Thank you.
Okay, so you should have the option to share your screen.
Okay.
Okay.
Are you able to see the slides now?
Yeah, we can see your slides.
Okay, thank you. So let me put it in the session. So hello everyone. My name is Albert. I'm from Team L. We named our team Synergy, where we will talk about our project related to the sustainable multi-use offshore platform. Interestingly, it is closely related to what Team K proposed before. So in our project, we want to seek a sustainable way to reutilize offshore platform to increase economical value through several options that we will discuss later. This is our team configuration, our mentor, Dr. Pandele Nukile, and we have 8 team members. So the background or motivation for our program is that nowadays, I think since 2015, more than 80% of offshore platforms in major fields need to be decommissioned. And we want to focus the decommissioning costs review taken in Nigeria and Southeast Asia can raise up to $9 million to $16 million per platform. It differs with North Sea area because in the area with rough weather condition like North Sea, the cost will be quite higher than in the area with calmer sea. Although the decommissioning challenges in this area that we want to focus on have some issue like cost spending, there are no economic benefits post decommissioning, there are limited shipyard in the area, and also the waste recycling activities that can create environmental issues. So there are an opportunity or solution to reutilize platform for such as fish farms, marine environment preservation, and renewable energy to provide sustainable options, not only for the operators, but also for stakeholders and governments as a sustainable system, which will create a multiplier effect and benefits for economical returns. Related to that, we want to focus on 4 UN Sustainable Development Goals, which are industry, innovation, and infrastructure, where we want to apply offshore structural health monitoring system for sustainable infrastructure, and then related to climate action and life below water, where we want to sustain marine ecosystem, and also create a renewable power generation in the near offshore platform area for climate improvement, and also to build partnership between operators, government, and stakeholders in energy and marine fishery sectors, which is related to UN SDG number 17. So in this project, we designed a roadmap to realize or to be followed. The first one is candidate selection. The candidate selection closely related to the domestic regulation of decommissioning. We use it as for reference. And we also need to gather some data related to the offshore structural condition like meta-ocean data, water depth and platform type, distance to shore. We know that in the area like Nigeria and Indonesia, we have a calmer weather data, shallow water depth with a lot of platform jacket type, which is suitable for our project. The second one is the deployment of structural health assessment system, which has goals to assess the structure's integrity. We install multi-sensors in the key areas. We compare it with the design parameters of the platform to estimate the remaining lifespan of the existing platform that will be decommissioned. We introduce condition-based maintenance and alert system, and we review the maintenance record during the operational activities. And then the third one is we perform the pilot installation program, where we attract investment on sustainable option facilities, such as floating cages installation for aquaculture, marine fisheries, floating solar panel near the platform area, or fixed solar panel on the existing platform. The other option are wind turbine support, but it is really related to the wind condition in the area. And also we can utilize it as a telecommunications gathering station or tourism facility. And lastly, we want to evaluate prior we can develop this project by reviewing the workflow improvement. We also want to discuss and have discussion between stakeholders, government operators to support the development of platform registration and to review the investment and the regulation process. So the decommissioning regulation in Nigeria and Indonesia basically supporting this project or creating opportunity for the project. A lot of platform jacket installed in the shallow water of Nigeria and Indonesia, with estimated decommissioning cost of one platform in Indonesia, for example, will reach around $7 million, and more than 100 existing platforms needs to be assessed for decommissioning because it has been operating with ages more than 20 years. So we want to create added value opportunity for marine and fish sectors by reutilizing existing structure. So the driving factors for our criteria selection, like I discussed before, is platform technology. We want to use the technology of platform jacket, which are installed in the shallow water depth. We use the structural health assessment to review the ultimate lifespan of existing structure, and also the weather condition and regulation in the selected area. Why we want to install or want to launch the project mainly focus on the discussed area, because under like we know in the North Sea area under dynamic loading and harsh environmental conditions, several structural elements are prone to fatigue-related cracking, which will increase the cost. And also the wind speed data drive selection for the efficient renewable panels, which are the solar energy. So the first one is the structural health assessment system. It is we want to deploy a monitoring system where we can improve the structural reliability with immediate detection of major structural issues. We also related to the result of the monitoring, it can improve the safety and the environment, the safety of the personnel working at the project, and also the environmental safety. It will reduce the long-term cost for the offshore platform maintenance, because we can detect how much is the estimated remaining lifespan of the platform, and we can reduce the expensive and unplanned equipment downtime. And also we can create a real-time alerts if any hazardous incidents will appear. As for our option for the sustainable development, the first one is aquaculture. 70% of animal protein globally coming from ocean and expected to rise up to 30% in 2050. Stricter regulation on coastal sea farming related to environmental concern provide an opportunity for an offshore aquaculture development, which will obtain the compliance on the regulation, create more spaces for higher production, which is estimated around 8,000 to 10,000 metric tons. The benefits for aquaculture, it will increase ocean food production, it will reduce reliance on wild fish stock, and it will improve the quality of food source, which is a good market. Moving the fishery facility offshore will reduce average sensitivity of coastal area related to the sustainability of the environment. The second one is the floating solar panel. Nigeria and Indonesia have high solar radiation and photovoltaic potential. Although for the floating solar panel, we know that the challenges are related to the maintenance operation because of the dynamic offshore conditions, the vessels deployment for the maintenance, and also for the installation, the environmental salinity of the ocean water. So we need to create a robust system for the floating solar panels, and also the proper cleaning. And the other point that I want to put is related to the area, because the floating solar panel will not use the land area, but we must see the proper area where it won't harshly affect the photosynthesis system of an offshore ecosystem. So we need a proper maintenance procedure and also proper seal for the panels for the efficiency. So our project synergy resulting in a cost saving and an increased safety, where we can utilize our sensor for the structural health management to check and to extend its lifespan and to reduce maintenance costs and also improve safety during overall operation. The aquaculture and fish farm option will provide a sustainable option for ecosystem and marine economics. Estimated a 5-fold increase forecast figure in the development of aquaculture in 2050. It will enhance marine fisheries for economic benefits, and it can improve environmental aspect of coastal area. And the third one is the renewable energy related to the floating or fixed solar panels. It has benefit of no land occupancy, reversible installation, and efficiency improvement. And lastly, this project will attract partnership not only from the operators as a technology and infrastructure provider, also from the governments to seek the regulation in the decommissioning process, and also the policy in the deployment of the renewable energy system and other sustainable development options such as the aquaculture, and also the stakeholders in the renewable energy for the economical benefits should create sustainable system that can be cooperate in a synergy. So that's all from me. This is our team, and also we kindly acknowledge the support of Dr. Claudio Tanasa, expert in offshore platform from SAIPEM, where we have discussion related to the offshore structure management. Thank you.
Thank you for your pitch, Team L. We would now like to invite the judges to ask any questions. Edward, go ahead.
Thank you very much, Albert, for that impressive presentation. It's obvious that the team's done a lot of background research. That was great to see. And I thought you had a really clear implementation plan and a good stakeholder list of people you want to reach out to, possibly partners. So really well thought out product and presentation. I have, I guess, two questions. The one is from your presentation, I guess I see that there's two solutions here. You're looking at aquaculture or floating solar. So the first is how you end up on one or the other. I guess the other is then a business, sort of from a business model. Do you see that diversification as a strength? So what sort of synergies do you see between the two products, the outputs? And have you considered any possible weaknesses of focusing on two outputs? Thank you.
Thank you, Edward. So we know that the offshore platform decommissioning cost, it's costly operation, which is very high. And when we want to invest in this kind of project, when we want to reutilize an existing platform which will not be used, let's say for the oil and gas operation, we need to provide an option that can create economical benefit, which can compete with the existing investment. So the first option that we are looking for is the aquaculture. Because the background from our teammates is Mr. Lorenzo. He's an offshore engineer. Because the expected consumption from the ocean marine fishery sector will rise in 2050, and also we have target to create a sustainable climate environment in the 2050, and we think that the aquaculture option will comply with this, where it will also provide economical benefits not only for the stakeholders but also for the government, and it can also improve the employment rate in the related area. And the second one, because of we know that if you want to decommission an existing structure of an offshore platform, it will be costly. So we think we thought that we need to install a renewable energy panel system in the offshore platform, but the area of the offshore platform is not very wide. So it related to the efficiency rate of our renewable panel, which are solar panel. Why? Because our region of interest is Nigeria and Indonesia. The wind speed in close to the equator area are very low, so I think it won't be too effective to install the wind turbines in our project. But to install a solar panel on the existing platform will require a lot of area. So we thought to improve the efficiency by seeking the option of floating solar panels. But as we know, although the floating solar panels will not use area like in the solar panels at the land, it closely related to the photosynthesis condition in the environment, such as what being discussed before from Team K about the algae development. If we install the solar panel above the sea surface, and if we cannot create like the efficient system to absorb the lights that will be used for the algae, the range of light that specifically be used for the algae for photosynthesis, it will disrupt the environment. So I think there are some of the challenges for the floating solar panels. Also, I mentioned in this presentation related to the dynamic offshore condition, different with the standing body water like on the lake or on the river, and also the high salinity environmental condition which require proper maintenance and also cleaning for the solar panels.
Thank you, Albert. That's really well explained. Thank you very much.
Thank you.
Okay, William, please ask your question.
Okay, thank you. My question is, the option you're talking about, you're focused on aquaculture and floater solar panel or power generation, let's say. So the issue is, if we talk about, let's say, power generation renewable, this is the same. Usually, we're talking always an energy company, so which is actually the owner of the platform, and they move to give new life to the platform, producing energy. But when we think to aquaculture, we're talking about another business company, which is not an oil company. So, did you take into account that then the company which is running the aquaculture has to manage an offshore structure which is maybe is not the same business? They have some complexity that have to be taken into account. Because actually it's owned by usually oil companies. So if you can explain something about this, if it's possible.
Okay, so I think thank you, William, for the question. I think I can share some ideas related to development in Indonesia. Actually, in 2019, there are studies to seek a way to transform the existing offshore platform facilities to reef, to create an artificial reef, which are already done in the USA, I think, and some study also done in Australia. For the offshore aquaculture, where our ideas was to deploy a floating cage system, which is less costly and require low maintenance effort compared to the submersible cages for the aquaculture. We want to propose that this project is integrated collaboration. I mean, because there are an interest from the government to seek an economical way to utilize the existing platform. I think the government will be like the center motivator or the center mover for this project to go, because it will create a cooperation or partnership, or it needs to attract partnership between the existing oil and gas operators and also the stakeholders for the aquaculture facilities, and also the marine fishery sector for the economical benefits. Related to the maintenance, that is correct, because in an offshore condition with the floating cages and for the technology in Indonesia or in Nigeria, I think it's not really familiarized with compared with what has been done in the North Sea area, which is already developed in a more robust way, and we need to evaluate and also see how we can improve the maintenance of the floating cage system, because we agree with what you mentioned, that it will also create like added costs during the operation of the project. But I think from the government point of view, because there are some interest to invest in this, it will be an attractive proposal to attract not only the existing operator, but also stakeholders, not only in the renewable energy, but also in the marine fishery sector.
Okay, thank you. Thank you for the answer.
Okay, so that concludes our session for Team L. Thank you, Team L. And last but not least, we now move on to Team M, team name Maverick. Team M's mentor is Marian Labrador, and the participants in Team M are Hamzat Hudulov, Enyo June Adojo, Azuruddin K, Elsiat Kitsbat Bey, Adiata Bajaj, Faith Bengal Boy, Chibuka Martins Okoro, and I believe Hamzat and Enyo will be pitching on behalf of the team. I have already made you co-host, so you should be able to share your screen.
Great, thank you very much, Ms. June. So I can share the screen. Let me know once you can see the screen.
Yeah, we can see your screen.
Yeah, great. Let me minimize this part. So yeah. Good morning, good afternoon, good evening. I'm Hamzat Hudulov. Today, together with June, we will represent Team M, and we call ourselves Mavericks. And first of all, before starting, I would like to thank our mentor, Mohammed Mahmoud, and other team members who supported us up to now. And also, I'd like to thank organizers and juries for your attention and for your taking time. So I would like to introduce our project that we call Produced Water Treatment and Utilization in Nigeria. So the reason why we choose Nigeria and what water treatment is, you can see from the figures, Nigeria is one of the highest population country in the world, and also from the figure you can see that almost 31% of people have no access to drinking water, and 42% of people has no access to improved sanitation. So basically, our idea covers almost 6 goals, from zero hunger to life below water, and including clean energy. And as we know, the water is a source of life, water is a source of power. So the almost 80% of problems in that countries, poor countries, the problems are related to water. So there are many problems that water can result, including malnutrition, ill health, absenteeism, business, and etc. And also, so it should be noted that it should be noted that the most of the children they cannot go to school due to these issues, because they are going after to find a water source, and that is a barrier between their education, their career, and themselves. So this is a key point. And what we offer is, as we know, each day almost 2.5 billion gallons of water is produced, and this water is treated and reinjected back to reservoir, or sent to another area, or sold to sea, etc. And we offer to retreat this water and use it in agriculture industry, or we can use it in the food industry, or as a source of drinkable water. And as a partner, or we can just work with the companies that already operating in those regions, such as companies providing water bottles, etc. So I'm sure that we can sell the water to them in a cheap price, that we treated water, and they can distribute it to the market industry. And also, one thing that is essential is the treated water can be used for green hydrogen production, which is nowadays the important direction companies try to focus on. June, please.
Okay, good afternoon, everybody. So I'm going to be taking over from Hamzat, and I'm going to talk a bit more about the water treatment process. So we already know that companies, for water that they have to dispose, they have to make sure it meets a certain requirement. Most oil producing countries have to make sure that their hydrocarbon content is about 10 milligrams per liters for onshore production, and about 30 milligrams per liters for offshore production. So the whole idea of this project is for them to further treat their water to the point where it's actually drinkable, where it can be used for agricultural processes. So you can see the oil droplets in the initial contamination. You have oil droplets, you have some dissolved matter and some other solid particles and sands and water and some debris from the well. Then you have treatments using dehydration vessels, storage tanks, and then it reaches up. Normally they reach up to the polishing treatment. That's when your dispersed hydrocarbons is about 10 milligrams per liters. But this time around, we want to go a bit further and actually treat the water to the point that it will be safe for drinking. Okay, next slide, please. Okay, so this is just a general idea of what the project involves. And as you can see in the picture, we have the energy producer, we have the produced water treatment plants, and then the water treatment plants, that's the extra treatment that will make it safe for drinking. And then the water that is being treated will now be suitable for domestic home use, for agricultural use, and for industrial use. And people think that, okay, the produced water is a waste product, but this is something that we can actually use to make life better for a lot of people. So it can be treatable for beneficial use, and as well as have a lot of implications in the agricultural, industrial, and domestic sector. Next slide, please. Okay, so we talk about in a worldwide scale, from study, we know that about 3 barrels of water is predicted to be produced from every barrel of crude oil. And this ratio actually increases more and more as your assets continues to age. And as some of us know, Nigeria is one of the top producers, top 13 producers of oil and gas in the world, and also has a lot of reserves. And we have a lot of companies like Shell, like Total, like ExxonMobil, and even plenty indigenous companies that are coming up. And so you can see the oil production is not in want. So we have a lot of avenues for you to actually use the to actually treat the produced water that they get and use it for this project. So some of the sources are, we're going to target reservoirs with high production of water that has been abandoned. So instead of abandoning it when it reaches the economic limit, we can use that, produce that water and treat it. Shallow reservoirs will also be another source. And like my teammate said, we also try and perform synthesis of the hydrogen that's from water that's using a process called electrolysis, that's splitting your water into hydrogen and oxygen. So this is our last slide, and we're just talking about the general process involved in the project. So of course, we need further research to be done, a lot more detailed economic analysis, but just with our 1 week research, we've been able to understand that a lot of costs are going to be reduced because of the fact that companies have to treat their produced water before any kind of disposal is done. So we take advantage of that opportunity and then go from there. Then the next is going to be the actual water production from the oil companies, which is something they already do, so no cost is involved. And then you have the water treatment. The project is going to account for that extra treatment that would occur. And then the processing and packaging. So this would normally attract a lot of cost, but we are trying to take advantage of partnerships. We're going to try and partner with bottling company and distribution companies. So we basically, like if, for example, we have a distribution company, Hamza Distribution Company or Hamza Bottling Company, so we can just meet with them, talk and have a kind of agreement and agree, okay, I will produce this amount of water, I will treat it and sell it to you at a cheaper rate, then you can now package it and distribute it at a cheaper rate so that people that do not have access will be able to get access to the water. So in summary, we're basically taking advantage of the largest volume of byproduct stream that's associated with oil and gas water, that is produced water. And we're trying to use it to provide easy and cheaper access to basic human requirements, that is water. So we'll try to take advantage of a partnership that will with people that will share like our sustainability mindset and work with them on packaging and on distribution so as to reduce our project costs. And this water can also be a source of green hydrogen fuel. So it's also another way to make sure the sustainable project actually helps to garner cost. So the cost we can get from selling the hydrogen after electrolysis, we can use it to combat our provision of clean water to the people. So I know we talk about technology and water, and as much as technology is very good for the advancement of the world at large, we also have to combine the technology with humanity, because we need to work together and try to achieve and ensure that people with basic people that have lack of basic human rights as water, like water, can actually get access to that. So yes, thank you very much. I think next slide are the teammates. Okay, so these are the teams involved: Aditya, Faith, myself, Hamzat, Chibuka, and Alciet. As you can see, we're from different parts of the world, and Azardine, sorry, as you can see, we're from different parts of the world, different time zones, but we're able to, try to come together to do this project. So I'm very grateful to every one of them, and a special shout out to our mentor, Mr. Mohammed Mahmoud. Today is his birthday, and I just want to wish him a very happy birthday. Thank you very much for listening, and God bless you guys.
Thank you, Team M, for your pitch. We would now like to invite the judges to ask any questions. Go ahead, Flora.
Thank you for your presentation. I understand the vital need to reuse water for human consumption. So what I'm wondering is, you sort of glossed over sort of what the business incentive is for this. So could you cover that again, please? Why would a company want to do this, or why would the industry want to do this?
June, will you speak, or?
From a business, what is the business incentive? How would you describe the business incentive to, for instance, the general manager of a facility or a company?
Yeah, basically, as we mentioned, people, companies are working in the country, and those countries, almost half of people have no access to water, and this is a terrifying situation. And this is we should find a way to support them, to help them, and companies also like already treat the water and dissolve it. So I think instead of dissolving, to like removing the water, they can just help the society, help the people, and yeah, that's basically it.
Well, it's more an economic question that I'm asking you. So has the team really thought about the economics of doing something like this, because it's an additional cost?
I think I can take that, Hamzat.
Yeah.
I think the primary incentive for companies over here is, as we know, most of the operators right now are transitioning, energy transition, and one of the applications that we proposed of the extracted water is production of green hydrogen. And that, I think, is a good enough incentive for the company to just show to the world that the company is interested in moving forward with the future of mixed sources of energy. That is one of the incentives, apart from the CSR side of the company. I don't know if that makes sense, but that is what we thought.
Thank you.
Thank you very much for the question.
Edward, please go ahead.
Thanks, Hamza and Enyo and Team Maverick for a great presentation, and a happy birthday to Mohammed also. I think this was really interesting that a few teams have touched on water use. It's obviously a really important topic at the moment. I guess similar to Flora, my question is a little bit about economics as well. I see with hydrogen, you've thought about storage and distribution rather than infrastructure. That's really interesting. You mentioned green hydrogen. I wonder whether thought has been given to the cost of electrolysis and then also the market for this product at the moment, and whether how that fits in with your business proposal.
Okay, I think normally it takes a bit of economics or a bit of money to actually produce the water and to further treat it, to distribute it, or to help gain access to help people that need water gain access to the water. And so this the hydrogen production part actually tries to offset some of the cost, so it to be a form of revenue for the project itself. And like my teammate said, we're trying to branch into a more renewable source of energy. So this hydrogen the hydrogen production actually takes advantage of that, because for hydrogen production, they can even use like co-produced heat and active solar energy to further introduce and promote the energy transition idea.
Okay, that's a very good answer, thank you. And also you talk about actually using the hydrogen element of it to offset some of the costs. Thank you.
And Flora, did you have another question?
No, I didn't. Sorry, I thought I lowered my hand.
Oh, that's okay, no problem. Okay, that will conclude our Q&A session for Team M. So after that, we will now be, this brings us to the end of the pitches for today's Ideathon contest. So jury, please remember to submit your scores using the Google form that was sent to you. A big thank you to the jury and the participants involved. So we will now be signing off. So please, but you can now join us for the sustainability panel, which is taking place in another Zoom room. I will send the link right now over in the chat. So here we go. So if you can all join us for the sustainability panel session, it's happening right now. So please click on that. If you cannot make the session, please be present at 10:30 CDT for the award session. This Zoom link is exactly the same as the one that I sent over in the chat. So just hit that click button and you will be entered into the award session. It's the exactly same Zoom link as the sustainability panel. So thank you so much for your time, everyone. We've seen some amazing pictures, and thank you for the jury for your time. And thank you ever so much for joining us.
Thank you. Wish you have a great day ahead.
Thank you so much, teams.
Thank you. Congratulations.
Thank you. See you later. Bye-bye.
Thank you. Bye.
Thank you, Ian. Thank you very much.
Thank you so much. Thanks, Cesar. I'll see you in the later panel session.
Yeah, thank you. Bye.
Thank you, Amina. Thank you.
Okay, thank you. Bye.
Bye.
Thank you, Ian. Bye.
Thank you very much.